All right. Welcome, everyone, and thank you so much for joining us today for our session about address points and boundaries. I am Caitlin Jamoka from the DataMark team, and I will be the moderator for today's session. Before we begin, I'd like to let everyone know that we are recording this session, and additionally, attendees have been muted for quality assurance purposes, though we do encourage you to ask questions through the use of the chat or the Q&A section of this platform. We can also share your questions with the presenters during today's session, or we can just talk about them at the end during the Q&A portion. All right, let's get started. I would like to introduce you to today's presenters, Drew and Mark. Please take it away for us.
Hey, Caitlin, thank you so much. And thank you guys for hanging out with us today. It's on really what I would consider, although it's not our last day of the conference because we're doing a user day tomorrow for some of our clients, but the last big day to really absorb a lot of content that we put together over the past few days. And before we get started, I've got to give a huge shout out to Commercial Electronics and our other sponsors for the commercials that they provided us for kind of the intro into a lot of our sessions. The quality of that stuff is amazing. So big thanks to Commercial Electronics and the rest of our sponsors. And thank you guys again for hanging out. Mark, this is a topic that you and I have done and spoke on a couple of different times, and it seems to draw a ton of attention. So that really excites me.
Yeah, and it's so critical for next gen because you want to have these address points, right? You want to have really clean boundaries, and that way 911 calls get routed properly the first time, which is huge.
Absolutely, this stuff is extremely important. So as Caitlin said, my name is Drew Fiorinelli. I am one of the public safety GIS experts and business development managers for DataMark, and I've got my good buddy and pal with me, Mark Whitby, here today. What's up, Mark?
How are you, sir?
I'm doing fantastic, man.
Good to be here. Thanks, Caitlin, for helping us out today. We appreciate it. Like Drew said, my name is Mark Whitby. I'm a public safety subject matter expert with DataMark. So let's kick it off. So this is a little bit about our agenda, what we're going to cover. Of course, we're going to talk about address points, right? But we're going to talk about that NENA document, that site structure address points. We're going to go through that. We'll talk about the CLDXF document. And then Drew's going to get into that GIS stuff, right? Because he's the GIS nerd of our group. He loves it and he talks really well about it. He's going to talk about those required layers in GIS for next gen. We're going to talk about data validations, how important it is. And one thing that people talk about but don't really focus on, data maintenance. And Drew really goes into this well and why it's so important. So let's talk about address numbers. Okay, NENA recommends an address point every 5.28 feet, which is awesome because there's 5,280 feet in a mile. So that's 1,000 addresses in a mile. Very easy for responders to go, I'm looking for 500 Alpine Lane. I need to go a half mile. And if evens are on the left, I'm looking on the left side of the road, right? Well, what if you live in a rural area? Well, maybe every 50.28 feet. I've seen that number before because you have less addresses on these long stretches of county or country roads, right? The NENA site structure address point document, really, really good document. And it's an informational document. It's not a requirement, right? It's not a standard, but it gives you some really good information about how do I place my points? What I liked about being on this NENA work group, there were a lot of people who were way smarter than me, so I learned a lot, which is always awesome. But one of the best things about this document is we give you pros and cons for each type of placement. You know, these are things you need to think about in your jurisdictions, in your counties, municipalities, your regions, or your states. But whatever method you decide on, you want to be consistent. Okay, so let's talk about some of these. Different methodologies. You can geocode, right from the Road Centerlines. You can be parcel based. So you put an address point in the middle of that parcel. Or you put it on the site. So maybe actually on the building itself, but some places go even further. What's the front access door, right? The front door of the house. Or for those rural areas where maybe you have your house is on 12 acres and your house is way in the very back on the last 2 acres, right? And it's surrounded by trees. How are the responders going to find that house? They're probably not unless they know that area. So sometimes we put access points on the road where they turn in, and then it's kind of connected to that site structure address point on the parcel, right? So point placement, if you put it on the centroid of that parcel, right? How many of you do this? Raise your hand. Okay. I know I did this in municipalities and counties that I worked, because it's okay. We know there's a structure or a building on that parcel. Well, then my next agency I went to, hey, we went a little further, right? So we said, hey, here's the building footprint, right? We're going to put it in on the top of that building. Well, can you go further? Sure, you can. You can put it on the access door for apartment complexes where each unit is. But again, what I really like is the advantages and disadvantages that NENA's document has for site structure address point that talks about, here's some advantages, but here's some disadvantages, right? Because you need to take everything all together and really encompass it and see what's going to work best for your area, right? Accuracy versus precision. This is always a good topic that Drew and I like to discuss. So Drew, tell me your perspective of these two and why they're so important.
Absolutely, Mark. This gets into something that I think really confuses a lot of people when they start either developing site structure points or starting to figure out how to manage site structure points. And it's important to acknowledge that while there's no right or wrong way, you do have to be consistent with the way you do it and continue to try and improve, because we're doing this for purpose, right? So we can be accurate. We can represent every parcel in our community with a point that sits in the centroid of that parcel. But when we think through that capability and the purpose we're doing that, does it really drive home what we're trying to identify from a first responder side, which is using that point to not only identify a specific location in space, but also a specific structure. So now we get into the accuracy versus precision argument, where this is accurate. I have a unique point for a unique parcel that identifies a unique location in space. But if we click to the next slide, we'll see that this is probably telling a better story for us, especially in parcels that have multiple structures. I really want to use that point to not only identify that unique location in space or that unique location on a road center line. I want to be able to quickly identify the structure that I'm responding to, because more than likely that's where the call is coming from, unless the call taker takes other details, like they're in a barn out back, or they're on the back 40 lot because they fell off a tractor. From my hometown, that's a common call because I grew up in a farming community, right? So think through purposefully about the process you're trying to achieve and how that's going to be used from a public safety standpoint, and then make your decision about where you want your points. This will also help drive the decision of, do you put the point on the center of the structure, or do you put the point on the ingress egress of the structure or the property? Because how we've seen this conversation evolve is, from a standpoint of consistency, if you're going to take that structure point and put it on the front door, make sure every structure has a point at the front door. You can't flip-flop and go back and forth, and we'll show examples later in the presentation of what that looks like. Also, if you're going to say, well, we're a rural community, we've got some driveways that are really long, so I really need to show access to the property. Think about creating a separate data layer that identifies property access and that point that sits at the road center line, so that you have an access point or an ingress egress point for the property. I have seen some states start to adopt that methodology, clearly identifying that it's not a NENA requirement, but there is a requirement in their community to show access to property, and then supplement that with a structure point that sits on the center of structure. So hopefully that makes a lot of sense.
It does. And again, like you said, think of it as a responder. If you were responding to that call, what information would you need? Hey, accurate's okay, but precision's even better. I know exactly where that address point is for that structure I'm responding to. So it makes a lot of sense. So geocoding was another option we talked about for placement, right? And there's been great debate over the years of potential or theoretical ranges versus actual ranges. So in the upper left, you have, for example, on the left, 133 to 167. Those are the actual addresses on the left side of that street. In this case, it would be odd. On the bottom right, you have that traditional 100 to 198. Well, notice the first address is 136. So you have all that empty space there. And then you have that empty space after 170 to 198. Whichever method you decide to do, that's your decision, but be consistent, just like Drew talked about. Don't do some streets actual, some streets potential, you know, one street 1 to 10,000, and then the next street 10 to 15.
1 to 10,000.
Right, all over the place, right?
You said 1 to 10,000. That's hilarious. But Mark, I think it's fun. We have to point out that, again, there's no right or wrong here, because we know dealing with legacy data, theoretical ranges still exist in our current data sets, and it may be mixed match from newer developments that are using actual versus older developments that are still using theoretical. So really, as you're getting into this conversation and this thought process, think through holistically and purposefully about whether or not you're going to make changes to that road centerline segment to make it actual versus theoretical. You don't have to do the entire database one way or the other. They can mix and match. Think about purpose, right? And I think, Mark, from your perspective as a 911 professional having to deal with this, I'm sure you saw a good argument for theoretical and a good argument for potential or actual throughout your time in the PSAP.
Exactly. And traditionally, MSAGs are potential, that theoretical range, because when we created these in the 80s, we put one street in that encompassed the entire county or the entire municipality, right, where on our road center lines, we break them into segments. So if you did the same thing in your MSAG, you would have multiple main streets with all different ranges. So again, you kind of take it into perspective. What's going to work for you in real life? What do your responders need? What does your 911 operators need? And how easy is it for the GIS team to maintain this data? We want to take that into consideration too, right?
Absolutely.
Yeah. So the CLDXF document, that's a handful to say with all those letters. You throw that X in there, it's like, but it's Civic Location Data Exchange Format Standard. Now, this is a NENA standard, and it goes really well with the GIS Next Gen Data Model document. So here's the NENA standard. And the whole idea was it helped develop a set of core elements for locations. Well, that's awesome, because we want to be consistent, not just within our county, but as we go and become a regional data set or a statewide data set, or with Next Gen in mind, a national data set, a national repository. So we want to have all these things match up. And a lot of it has to do with things like parsing our data. You know, traditionally in MSAGs, we have one field for street name, but it has the street name, the street type, and the post directional. They're not broken out. But in our road center line and our address points, it's broken out. So when you compare those data sets, it's a challenge sometimes. But this document took into account the FGDC, right? And ERISA and NENA, they all work together. So it wasn't like just NENA came up with this idea and said, hey, we're NENA, we're going to force everybody to do it. No, we talked to a lot of different groups and said, what's a best practice for everybody? But it's going to benefit 911 because addresses are what we do, life and death. So in the Next Gen GIS Data Model document from NENA, traditionally there's 4 fields that we use currently. We use pre-directional, so north, south, east, or west, those kind of things. Street name, street suffix, so boulevard, parkway, drive, and then a post-directional. Well, that's okay. But as NENA started getting data sets from all over the US, they were like, some of these things really don't fit traditionally in this system. So they added 4 more fields, and you're thinking, oh no, I got to add all these fields. Oh my gosh. But some of these are really crucial as you move forward. For example, the first one, the pre-modifier, alternate route 8. Okay, well, traditionally we have it as alternate route 8 as the street name. Well, alternate in next gen is going to be the what they call pre-modifier. It's not really the street name, right? But it's before the street name. The pre-type separator, and I've seen these in a lot of areas. Avenue of the Carolinas is in North Carolina. It's always been a weird kind of sounding name, right? Where does of the really fit? So this is where we're going to put it, in the pre-type separator field. Another one is the post modifier. I really like post modifier because there's a lot of streets I've seen in MSAGs all over the US that have things like extension or extended at the end. And we didn't really have a place for it because it falls after the street suffix. And then another one they added was pre-type. I was looking at an MSAG earlier today. Avenue A is a street in Polk County, Florida, okay? Like the Lakeland area. A lot of counties have these. Pinellas County, where I worked, had it. Where does Avenue really fit? Because it's really a street suffix, but it's before A, which is the street name. So again, very convoluted. So NENA thought of this and said, this is where we're going to put it so we can parse all these out. So when I share my data with Drew in the county next door or in a different state, it's all consistent. And that's important. Same thing with address numbers. So traditionally we have address numbers. Wisconsin is a lot of their MSAGs have like W001423 as the house number. Well, in the future, we're going to use that W00 as what they call an address number prefix, because it's not really a number, right? It's not the house number. And then we're going to add a suffix field. In Pinellas County, where I worked, St. Petersburg, Florida, was notorious for adding 1/2 addresses. Because back in the day when they built these things out, they built 101, 103, 105, 107, and then they split the parcel and say, we're going to add another address with 101. Well, I'm out of numbers. What do I do, right? So we'll make it 1/2 or 1/4 or 3/4. Oh, I hated that. But now we have a place to put it. And then there's also going to be an optional field where you can put things like milepost or additional information related to that address number. For example, Hawaii uses a lot of letters and numbers before the address or part of the address. So for Hawaii, they had to take that into consideration. But a lot of places do that. And then one of my favorites is subaddressing, right? Subaddressing is so important as a first responder. But they broke it out and they really got really granular. So they have building, additional location information, floor, unit, room, and actually all the way to the seat level. Well, I know where I worked in Pinellas County, we had a lot of condos along Clearwater Beach, St. Pete Beach. So we needed those unit numbers in those condos and what floor it was on and what building of the condo it was on, because if we had to evacuate for hurricanes, we had to give them a pass to get back onto their property. It had to be at the unit level. If you have a big business complex, maybe you can get to the room or seat level. It's great if you can do it, but just think about the maintenance part of that. What if they change and Drew's in seat 2 and Mark's in seat 4 and Drew gets promoted and now he's in seat 2 and 3. They make him a bigger office because he's the man. Well, now 3's gone, but we have 3 in our data set, right? Oh man. Or Mark transfers to another department. Now I'm in seat 12, but they never update the phone records or the data set, right? So you have to have the staffing and the resources to maintain that. Let's give you a little update about the NENA GIS Data Model document, right? NENA's always updating information, but that data model document is huge. So they created 2 smaller working groups. They had an emergency service boundary working group and a road centerline working group. And I was fortunate enough to be on both of these working groups. So we worked through our process, got all the information done, And then they combined a group from both groups and some people from like the outside with NENA. And what they did was they've been trying to put it all together. Okay, well, now that they have it together, these working groups are going to get back together and kind of sift through to make sure, does it make sense? So there's going to be a newer version, more specific for certain things coming out soon. So if you are a NENA member, get involved with work groups. This is how I learn a lot of the things I've learned. But keep an eye out because these documents will be coming out for public review. And once it comes out, you can use it to help you with your data. All right, Drew, I'm going to turn it over to you.
All right, thank you, Mark. I tell you, we've actually gotten a couple of questions come in during your conversation. Some of the questions that we've got we'll address here in the next couple of slides. So I'm not going to ask you here, Mark, but we did get a great question. One of our participants is from rural Ontario, Canada County, and there's actually two questions related to water access only addressing. So an island, think of an island, you have to get to it by a boat, and you have structures that are addressed on the island. So response over water to remote shoreline or island, where does NENA address points or center lines or addressing for islands, or do they?
That's a really good point. I don't remember seeing anything about it, but I know I had to deal with this in Pinellas County, and we had a client that asked us, where we actually just created a road center line on that island and addressed, named the street, and then we added address points for that. Mm-hmm. But then you would have to like additional location information. This is an island, accessible only by boat, right? Water rescue, those kind of things would have to be in either your GIS data set or in your CAD system. Mm-hmm. So, but that's a good question because I know Canada has worked with us on our ESB group and our Road Centerline group because they're coming up with their own standards and we wanted to incorporate those. So that's a great question.
I do think it's a great question. It's a great reminder that while we just went through some of the parsing requirements for address points via CLDXF, what you didn't see is put up there is there's a descriptor field that you can keep in every attribute table where you can provide a description, like Mark said, this is an island, this is water access only. As far as an addressing standard, I think the same standards would apply that you use in your locality for addressing something that's on an island or something that's on a lake. But you may use additional sub-addressing if there's multiple structures on the island. We're kind of treating the island more like a college campus or a university where there's a single mailing address point, but you're trying to uniquely identify different structures. And I could see where that could get really confusing, especially if there's no road on the island, right? Small enough island that's either has a single owner and they have multiple bungalows or cabins, and you just walk everywhere, or you ride ATVs or golf carts. So really interesting question as it relates to islands. I hadn't put much thought into it, but I like it.
Yeah.
All right, so as Mark is showing, we're showing, I know that you guys know this. I know that you've seen it. The required data sets for NG9-1-1 geospatial call routing, your PSAP boundaries, your road center lines, your emergency service boundaries, your address points, and your provisioning boundaries. However, we are specifically going to focus on the GIS data address points and road center lines. Next slide for me, Mark.
Yep, hold on a sec.
Did you click off of it? All right, so as we know, address points are a required data set for geospatial call routing in the Next-Gen 9-1 environment. This is the most precise call and resource routing data set that you have. It is structure-based. We encourage the utilization of sub-addressing. NENA encourages it. There are some tips and tricks for really understanding sub-addressing and incorporating sub-addressing. And this would also include non-addressed dispatchable locations. So a transfer station or a landmark, you may address a landmark or take advantage of really utilizing address points to identify holes on a golf course like they've done in several communities in Florida, which I think is a fantastic idea. But I do want to point to the image that we have here and kind of refer back to that precision versus accuracy argument. This is something that we see often when we're working with clients on their data, where you see this hodgepodge or this mix match of where to place the address point, either on center of structure, kind of where you see on the middle part of the image to the right, versus at the road or in the center of the parcel. You can see how that might be confusing to someone that if we drop the imagery and we just threw up some road centerlines in the address points, are you automatically going to think that each point represents the center of a structure or represents a house? Now, where this could get more confusing is I've actually worked with clients to help strip apart their address point data and pull stuff out that wasn't necessarily necessary to be in there, like water valves or manhole covers or fire hydrants, and really encourage the best practice use to pull those data points to their own separate layer so that it can be turned on and turned off or utilized differently when we're resource routing or we're providing that data to our CAD map to provide a more holistic picture of what the scene looks like. Situational awareness, right? All right, next slide for me. All right, subaddressing. The process of identifying multi-unit structures who share a common mailing address with unique identifiers. Most commonly, we see this colleges, universities, military installations, shopping centers and shopping malls, strip malls, apartments, and condos. Now, what does this actually mean? Well, as someone who's managed addressing data at local government, typically the way we see it on our labels is the way that we've stored it, right? Where we have 527A Woodside Street. Well, 527A is the house number. Okay, that works perfectly fine, good and well for parcel mapping or for tax assessors, but for next generation 911, we really need to pull that A out and put it into its own field, that it's its own attribute, so that our house number can be 527 and the subaddressed unit number is A. So now we actually have a unique identifier. And if we don't do that, if we want to continue to use whatever that mailing address is, we get the example that we see here on the screen in these apartment complexes where you have, gosh, 30, 40, 50 address points that are all the same, right? 43 Delaware Avenue. That creates a problem for geospatial call routing because one, it may not know where to dispatch the call or where to send it to, or it puts you in the center of that campus. Well, what building did it come from? Mm-hmm. Right? Really big issue on colleges and universities, especially if you're not familiar with where you're at on campus, because all buildings on most colleges and universities utilize someone's name. Yes, you can call 911. It's highly possible that they have that name in their system, but that name may not be attached to a point in GIS. Right? So we get conflicting information by what we know versus what we see. And it can create a lapse in response time, which is really what we're trying to use subaddressing for, is to increase our rate of response for emergency response in 911. We are actually in the process of developing addressing plans for colleges and universities to help those universities maintain their culture and maintain their image, and really reserve these building names that have been on these buildings for decades, but provide a better system of methodology for response in the background on the GIS side, right? By identifying subaddressed units or building names and street names throughout campus. So it's a really big issue that we see a lot that is slowly starting to gain traction and identify solutions that help maintain identity while providing better service for public safety.
And one thing that you can also point out too is a lot of times they go, oh, our fire department knows where this building is, or our police officers know where the building is. Think about mutual aid. Mm-hmm. What if that police department is busy with a major incident and they bring in the neighboring town officer or a neighboring fire department who have never been on this campus? Right. They're just going to drive around looking for it unless they have campus security or something like that that can direct them. So think of it that way too.
Absolutely. And then we also want to look at our boundary data. So we're going to start with our PSAP boundary data, which we know is required. And this is for our primary PSAPs, it's not for our secondaries. This is that needed footprint for identifying our primary PSAPs and our neighbors' primary PSAPs. Because as we evolve this data and build our relationships internally and externally to our locality, we're going to have to know where that data is or where those boundaries are so that we can perform checks, right? These quality assurance checks, these validation checks to ensure that there's no gaps, overlaps, or duplication of polygons internal to our organization and external with our neighbors. While we know internally we can't have any gaps or overlaps in our data, in our like data, we can't have it with our neighbors either. So we're forced to build relationships with our neighbors that hopefully we have good relationships with already through established MOUs. But things that we want to look for in the GIS world are slivers in our data as well, which can create a gap or an overlap. So if you look towards the bottom left, you see the red polygon and all the little slivers of polygon in there. We have to eliminate that, because on the rare chance someone calls from that gap or that overlap, it really throws a whirlwind into the geospatial call routing process, and it doesn't know where to send the call. And so it's going to use a secondary method for transferring the call or routing the call to the correct PSAP that could be the wrong PSAP. We just don't know. So we want to identify that and eliminate it. And the easiest way to do that is to pre-validate your data to look for these things before it's provisioned into the ESINet. And on the right side of the screen, you see that half arc moon-shaped sliver there? I don't know what it is, but I feel like it doesn't belong there. And then you also see the dotted lines there. That's a duplicate polygon or a duplicate feature that's drawn on top. So if we were to select that in our desktop environment, we would see that it selects 2 or more features. Well, we want to get that down to be 1 because everything needs to be consistent and coincident when we're dealing with our boundary data. And the same is for our provisioning boundary and our emergency service boundaries as well. So next slide, Mark. So in our provisioning boundary, we know that this defines the area of GIS data that we're provisioning. This is also identifying the GIS data that my PSAP or my locality is responsible for maintaining. So I'm the data editor, I'm the data maintainer. I am responsible for everything in that polygon. So this is the easiest of the boundaries to identify because more than likely it's going to mimic your municipal boundary or your county boundary because you're responsible for the data that's within your county. So it creates that geofence and the spatial interface as well, so that when anomalies are identified in your GIS data, it knows where to send the anomaly report to what PSAP to let you know that there's an issue with a piece of data. So I love this boundary because it's the easiest of the 3 boundaries. Where it gets a little difficult is our next one with our emergency service boundaries. We all have some sort of fire response layer or law enforcement beat layer or an ESZ or an ESN layer in our GIS, right? If we don't, I guarantee you have something that is referenced to a response of some sort layer. It's no different, but it's a little different, right? So whereas that single polygon may be split up into different pieces to identify who's going to respond to what area of the county, we now need to separate that one layer out into 3 individual layers, identifying a fire layer, law enforcement layer, and an EMS layer. And within those that are the same, let's take fire an example, because I've been responsible for having to draw first due response areas for each of my engine companies in my county. All right, easy enough, right? Well, because it's my fire ESB layer, I can't have any gaps or overlaps between the different polygons in that layer that's representative of those fire response areas based on station. Now, I can use that as an overlap for my law enforcement or on my EMS. So different layer types can overlap each other and have gaps, but in same, no gaps or overlaps. Oh, and also, after you create these, work with your neighbors to make sure your ESB boundaries match up to theirs at the corners or at boundary areas. because you don't want to end up with you're responding to the entire road, but they're responding to half the road. It's going to create an overlap. Or you're going to one curb or sidewalk and they're going to one curb or sidewalk, and it creates a gap between the two response areas. Or maybe for 20 years, you've responded to Sunset Meadows subdivision that's outside of your county boundary. So you've incorporated your fire and EMS ESB to cover that subdivision, but the new 911 director for the neighboring county doesn't know that. And so they've incorporated that subdivision in theirs because the subdivision's in their county. Well, now you have a massive issue when someone from the subdivision calls 911.
Yeah,
Where's it routing the call?
Right, where's the call go and which resources are coming, right?
Yeah, absolutely.
Those mutual aid agreements are huge, having those. And a lot of places, you know, back in the day, it was a handshake agreement. Drew's a fire chief, I'm a fire chief. Hey, Drew, you're closer. Would you mind going there? No problem. Shake hands over a cup of coffee and that's it, right? Now we need to document that because you can connect that to your GIS data. So when the new fire chief, Drew retires, new fire chief goes in and goes, why am I going over here? It's closer for you. Well, Drew and I, no, here's the documentation. So
absolutely. And you know, that's something that we're going to start to see more and more of, is that institutional knowledge that our current leaders have. As those leaders retire or move on to take different roles or different positions, that institutional knowledge goes with them. So make sure that you're working with your 911 administrators, your fire chiefs, your sheriffs, your police captains, your beat cops, from both sides, your county and your neighboring counties, because that's a lot of valuable information that can be used to help you design and articulate out emergency service boundaries, PSAP boundaries. And before we move off of boundaries, we do have a question related to address points. Got a question on how we would recommend addressing a single structure that houses two businesses. You would use a subaddress. So I'm going to say that structure has the same mailing address, 1213 North Main Street. You would apply a subaddress of some type, an A or a B or a subunit type for that structure, so that you now can identify each individual business, one by name because you have a descriptor field in your attribute table, and two by unique identifier using a subaddress. That's what subaddressing is supposed to handle. So I hope that answers your question. And we have another, what about a house with a basement that has been converted to an apartment that the owners want a separate address for? Mark, that's a good one, because it doesn't have to be a subaddress.
Well, it could be a subaddress because currently the postal standards have an abbreviation for basement.
Right.
If it's a separate location. Would you want to give it a separate address? Maybe.
Yeah.
But you could still put like lower or basement in there as a subaddress to definitely differentiate, because if, say, for example, you have a second floor and they subaddress that one or have a separate address, responder gets there. Am I going upstairs, downstairs, or in the middle, right? Which one would it be?
Great question.
Yeah.
And so a lot of times where the owner of the structure is requesting a separate address for a basement or an apartment, most localities have addressing ordinances that will address that. So it could be against the addressing ordinance to establish a separate address for something that sits on the same property. They'll probably lend you more towards identifying a unit number or some sort of subaddress type. And this works the same for skyscrapers. So whether it's 2 levels or 45 levels, you probably have an addressing ordinance where level 1 will be a 100 block, level 2 is 200, 3 is 300, 4 is 400. And if it's an apartment building where you have individual units on the floor, it's a derivative of 100. So 101, 102, 103, that gives it a unique identifier. Or floor 100, it's 100 Main Street, and then you have a subaddress for each unit. Now, in something that a little different, where it's mixed use, where it's business and residential, where a business may take up the whole floor, then they may have one mailing address that gets them to the floor, to the main office where the receptionist is, and each individual office may have a subunit type or subaddress. so that you know calling from my office in X company building on the fourth floor, the call is going to come into dispatch as 423 North Main Street telling you that it's the fourth floor, unit B telling you that I'm in office B. Does that make sense? So it's really identifying unique identifiers for each structure, but you have to be careful because as we saw in CLDXF, you can get down to room, you can get down to room number, which is the skyscraper example or the apartment building example, but you can also get down to cubicle or seat. Be careful with that because it's really cool for data nerds like me. It's impossible to maintain because you're relying on information from the building owner to let you know when they've redesigned a floor so that you know to remove these seats. Now, if it's an auditorium or a coliseum or something where you have seats that are immobile, they're affixed to the ground, sure, might make sense to create a data point for every chair in the coliseum if you want to. Like, gosh, a football stadium. How much better would it be as a responder if you're responding to the national championship football game and somebody calls 911 and you know they're in section B, chair 243? That's cool. Do we have the technology and the capability to do that? Yes, we do. Do we have the time and the resources and the manpower to map that out? Not without effort. All right, next slide for me, Sharon. Data validations, right? So in NENA's data standards, or it's the data management requirements document. It's a 28-page document. I encourage everybody to read it. If you hung out with me yesterday, I talked to it quite a bit, and we talked about the value in validating GIS data before you provision that data into the EZNet environment. I'm going to have to go really quick, guys, because we've only got 7 minutes. However, if you have questions and we can't get to them, you will see my contact information marked at the end of this presentation. Call me immediately and I will answer every question that you have. Well, we need to pre-validate our data because if we take our data as it is, we've migrated over to the next-gen data model or whatever state data model your state has provided you, and you just throw that into the core services environment, it's potentially going to spit out a ton of validation errors or a ton of just issues and anomalies with your data that now you have to go back and fix before you can re-provision that into the EZNet environment. And if you pay attention to the documentation, it states that you have 3 days to make any corrections that are found in the data. Well, if you've got report after report after report and anomaly dump after anomaly dump to fix, it's impossible to tackle that in 3 days. It's impossible to tackle that in 2 years. I've done it. It's not fun. However, you are encouraged to pre-validate your data. So identify a vendor, identify a process that will work with you to develop validation rules or a validation engine so that you can pre-validate your data repeatedly and build that into your workflow and data maintenance processes so that you can tackle all of those anomalies upfront and early, and then get the data to where you would like it to be above a 98% accuracy match, and then work on provisioning that into the EZNet. However, if your state currently does not have an EZNet, this is the perfect time to validate your data. Now, we've been in conversations where we talked about validations, and I always get somebody to raise their hand and they're like, we got it. We don't need this great conversation. I'm like, oh yeah, what are you doing? CAD takes care of it for me. I'm like, yeah, not really. There's a difference between CAD validations and next-gen 9-1-1 validations because CAD is primarily looking at the tabular component of the data. It's not looking to see if the data is spatially accurate and representative of reality. That's the biggest piece. CAD is also not looking for topology errors, right? It's only looking to match your address point layer with an alley record or a road centerline range with an MSAG range. It's looking for a 1-to-1, right? It's so limiting. So when we get to next-gen 9-1-1 data validations, it is so much deeper because our data acts as a pre-validation process for 9-1-1. Right, and we just covered this a little bit where our road center lines to our MSAG, we definitely want to do that validation for next gen to make sure our ranges match, our road names are consistent, our road types are consistent, We're all human. We can all fat finger something any given day of the week. The same with our address points in our alley. So not only are we wanting to check the spatial accuracy of our data, we want to compare it to the data sets that are currently being used to support 911, our MSAG and alley. Do we have one-to-one matches? Is our sub-addressing matching? Where does a street name, a street name change from Main Street to Main STR back to Main ST? That's an anomaly in the data that we need to correct before we provision our data. All right, and then here's something that I've thrown up here that gets you thinking about developing a process or a plan for doing this. So if you don't have a strategic plan for Next Gen 911, I guarantee you your state does. Review that plan and see how you can implement that locally. Identify different data sets that you can compare against each other to perform something like an address comparison and evaluation. Happy to talk through you with that. And then as you remediate your data after pre-validating it, think in terms of how that data is being used and how it was created to drive your data remediation and your error correction process. You want to address issues on the road centerline first before you address issues within your address point data, because our address points come from where they sit on the road centerline. By flipping it, you potentially create more error than you correct. So keep that in mind as you start remediating and validating your data. Next slide for me, Mark. All right, and then fishbone analysis, we're going to talk really like 2 seconds on this. Check it out. Google fishbones. Esri has a process that you can walk through to create your own fishbones. I also know of a process where you can create fishbones. This is fantastic because what a fishbone does is it maps your address point to the road segment where it would fall. Think about the impact this has when you're routing a resource. What part of the road segment are they going to land on if they're using a GPS device? This is a good indicator of where that's going to happen. It's also a good indicator of where you have points that are mapping to multiple road center lines, identifying an overlap and address ranges for multiple street segments. All right, I said a whole lot right there. Address point duplication, sub-addressing is the biggest cause of this. Next slide. We got to go really fast. I'm sorry, guys. Identifying address points that are misordered along a road center line. Right? That could be a multiple of different reasons, but it's something that you want to look for, whether you're using a vendor to help identify it or you're developing a process internally. And then skip through the next couple of slides for me, Mark. We got 1 minute. Then we talk about some topology issues. Happy to show that for you. But there's a reason that we do this, right? It's important to reconcile your GIS data because now it is life critical. This is a new position for us as GIS professionals. We haven't needed to support our data to a level where we were relying on it to save a life, but now we are. And then data maintenance is a big piece that I would love to talk more about. We're just running out of time. Why? Incorporate data maintenance and data remediation and data validation as a part of your workflow. It is going to be important and ensure that that data stays at a high level of accuracy. And the next slide, I think your questions, bam, we got there. Can the slides from this presentation be shared out or sent out? Absolutely. If you will send me or Mark an email, I will shoot you a PDF copy of the slide deck. If you have any questions, my number's on the screen, Mark's number's on the screen. I'm going to be more your GIS guy who's 911 okay, and Mark's going to be your 911 guy who's geo okay. Woo, that's a whirlwind. Why does this always happen to us, Mark?
I don't know.
We get great questions. That's why.
We do. Thank you for your participation, which is awesome.
Hey, for you guys that shot questions out on the islands, high five. It's something we've never had a question about before, and the many times we've done this presentation. Love you guys for that. All right. Thank you so much, Drew and Mark. That was a great presentation. Please join us for our next session, the Northern Colorado wildfires and the use of GIS data and emergency evacuation orders. That will begin at the top of the hour, so just in a couple minutes here. All right, thank you so much, everybody. We appreciate you all joining, and we hope to see you in the next session. Absolutely. Thanks, guys. We'll see you later.
Thank you.